Well, this now completes the formal portion of the meeting, and we're going to now transition into the management presentation by Michael. I just want to point out one thing. It was appealed to me and several of the board members that we should bring out our inner Michael Levy, so I have gone all black today. I don't know if I can carry it off as well as Michael does, but I'm going to give it a shot.
Yeah,
I have a little more hair.
I got the other half, right? So I got the black jacket and the black shirt, but not the light pants. I couldn't go all the way.
How can we go wrong with that? Go ahead, Michael. Thanks.
Perfect. I didn't know that.
There we go. Well, good morning, everybody. This is a really exciting time. We've had a great year. In fact, I think the last time I saw everybody was 3 years ago. A lot of people. I saw quite a few in Belgium last year, and that was a really fun talk and a fun meeting. A lot of excited folks. But today, over the next 45 minutes, I'm going to give the management update. And I'm going to talk about what we've achieved in the last year and where we're going. And so let's get started. So, of course, I've got to show this slide, and you don't have to read all the words in this slide. But we'll get off this slide pretty quickly. It's a safe harbor slide. But this is it. 3 words. Should I sit down now? We finished? So, yeah, we are really excited. And I just wanted to get that out up front. It's been a great year for us. You know, we've seen a lot of things occur. Everybody in this audience room has seen a lot of things happen to the company. But then the next slide is really interesting. And I think most folks were aware that we went on to the NASDAQ last year. And if you think about it, my first time giving this talk was 2017, which was 5 years ago. And if you look at the takeaway line at the bottom, we promised, I know Tom and I promised in 2017, we do an organic uplist, without a reverse split and a natural uplist to the NASDAQ. Because, you folks were asking, when are you going to go to the NASDAQ? And we said, we'll do this, and we'll do it in our own way, and we're going to get our technology to the point where we could do it naturally. And that's what we did, and it's just been fantastic to do that. And in fact, this guy here, Andy Hall, is the executive at NASDAQ. I mean, you can look at that photograph and you think, well, there's nobody in Times Square. It's because these guys had all these security guards go out and clean part of Times Square so we could have a photograph taken. And he said to us, he said, I've been doing this job a long time. I don't recall another company that's done this. And so it's rare. It's really cool. So I started that photograph on the top left. I mean, where does this come from? Because of COVID, I had to take my wife to Hawaii a couple of months earlier, and everybody was doing the hang loose. And it was more of a spontaneous thing. And it's like, well, this is an L, and this is another L, so let's do that. And it actually happened on the day. And if you look really closely, you just can't see it there. I have a green ring, because everybody had to be COVID tested to go into the NASDAQ building. And I don't know, I just felt really excited at the time. And, look what's happened in the last, 6 months. Everybody's doing this, right? It's amazing. LWLG, I mean, the company is great. It's a fun place to work at. We've got world-class folks. We're doing great technology. We've come a long way. And if you think about where we were a year ago, I mean, just in, if you take one metric, just take the share price. I mean, it's completely changed. And so we've done really well in the last year. And I think you see the excitement in the team, you see the excitement today. And this is very unusual. I don't usually get this excited. I'm quite a conservative person. I mean, I don't usually wave my hands. I mean, one of my colleagues, I think you remember last year, Jose Pozo from Epic. And I was in a video with him, and he's like this. I just don't like that. But in this occasion, I mean, I'm wearing a white shirt, and you will never see me wear any other color than black. Right? So, yeah, we did great. And then while I was standing outside with Andy, I had a text come in. And I don't think I've told many people this story. And the text came in from my brother-in-law in D.C., who's a financial guy. And he was watching it on the TV with his family, the whole sort of pressing the button and ringing the bell for the end of the week. And the text that came in on my phone was, "Why is Uncle Michael showing gang signs on television?" And so I show the text to Andy. He's falling about laughing. It's like, well, I didn't realize this is a gang sign. But great. This has been a great start to the year, and we worked hard to get there. So the talk, if there's nothing else, 4 takeaways is what I want everybody to take away from this talk. You're going to hear a lot of information. There's going to be a lot of data. Some of it's going to be technical. But, you know, the slides will be available, so you can look at the slides afterwards and you can pull them apart, and I'm sure you will. But the 4 takeaways, we've made unparalleled progress in the last 12 months. The second one, our technology is competitively superior and unique. The third one, we are positioned to have polymers become, and I think everybody knows this word, I've been using it, ubiquitous, right? And the last one, which is really important for tech companies, we have the resources and the plans in place to succeed. So these 4 points, this sums it up. And this is, if there's anything you want to walk away from this meeting, there's these 4 points. So let's look at the outline. And so there's the normal outline, what we do, the dynamics, the markets. But the most important thing about this slide is the bottom part. And I've actually indicated in red font new guidance, because what we want to do in this presentation is give more guidance. I mean, everybody's been asking for guidance. I'm sure there's 5,000 questions in Q&A about guidance. And so when you see the red font, this is stuff that we haven't talked about before. So what do? So this is a simple slide, and there's not a lot of detail here, but let me go through the points. We create our own materials that are unique. These are polymers. Our materials switch light really quickly. And if you want to try and compare that to something else, you compare that to like liquid crystals that used to get used in TVs, but they don't get used in TVs anymore, and they could switch light, but it doesn't switch very fast. Our materials are ideal for a faster, lower power internet. Our materials are polymers. In fact, we look at polymers every day when we look at our televisions and our phones because of the OLED displays. They're polymers. Our polymer materials are used in modulators. And modulators are the devices that get used in the internet to switch the light. Our modulators are very small, and so they fit easily into the boxes that are used in the internet called pluggable transceivers. And this next bullet point has a couple of green highlights here because it's really important. Polymer modulators have transformational performance and headroom for decades. So what does that really mean? It means the performance of our modulators using polymers are not only good for today, not only good for 5 years or 10 years, but decades. They have that performance runway, if you like. And start using these things, they're transformational. And so, yeah, I've worked in some startups before, some hot startups in the Bay Area, and you've got great technology. But this technology is transformational. This is really cool. And then the last bullet, we can integrate other devices with our modulators. So you can do modulators with silicon photonics. You can do multi-channel solutions. You can do a number of them. So they're quite flexible in how you design them. But the takeaway for the slide is polymer technology extends speeds, reduces power consumption, not just for a few years, but for decades. And when you talk to customers, this is really important. Because customers will say, well, this is great technology, but what's next? And what's after that? And so you need to have a roadmap that keeps them really excited. So market dynamics. This is a slide from the Ethernet Alliance. I've used it a couple of times. But what it shows here is that everybody is looking at standards to go higher speeds. This relates to the speed of the internet. And the thing I've ringed here is the path to single lane. The only way you can really really get to achieve these speeds is to have a very fast optical switch, a modulator. And that's what we have. Single lane, you have to have faster optics. So the industry is putting out these roadmaps, and we have the technology that actually fits to these roadmaps. This one is a complicated slide, so I'll simplify. I'm not going to go through all the details, but you can see there's two big arrows here. And there's the red arrow, which means the power consumption is just going up. And you can see the slope of that curve is horrific. And there's some big numbers there. And that red arrow represents data centers' electricity. And if you look into data centers, you realize they are consuming tons of electricity. And it's a problem. You use a lot of power, then you've got to get rid of a lot of heat. You've got to cool these places. So you're looking for low-power solutions. The other two curves here in blue, or the blue arrow there, traffic, that's the internet traffic. That's because we're all using video platforms these days. And so we're using more data. We want more bandwidth. And that's going up too. So that's a problem for the industry. It's a major challenge for the data centers and the service providers that provide our internet. And so power is growing exponentially with increased traffic levels. It is the Achilles heel of the industry. And this is happening today. This is public information. And to address this, you've got to have better technology. In fact, we were at, a few of us were at a big conference in March called the Optical Fiber Conference down in San Diego. And this slide is from Arista, who's one of the big players that does a lot of data center type transceiver modules. And this is the slide they put up. Cloud network bandwidth and power. The cloud bandwidth is growing at 50, 60% a year. You've got to figure out how to get the power per bit. And it's declining. And there's a disconnect. There's a disconnect between the traffic and the consumption of power. And we are able to address that. And so growing bandwidth brings higher power. Power needs to be mitigated as speeds increase. And we have the technology to do that. So let's have a look at the target markets. And now this slide has a lot of markets. And you can see as you go down the vertical on the left-hand side. But the top four are colored in green because they are existing. They're here now. They're really exciting, and they're a perfect fit for our polymer modulators. And you can see, depending on which market research you use, whether it's today or it's out to 2030, these are big markets. So there's huge opportunities here. But you also see below, there's other markets too that we see are opportunity for our technology. We're not a big company. We're a small company. So we are focused on the green. We need to go nail that green. And we know there's interest in displays, projection, automotive LiDAR, different types of sensing. We know this. But we don't have the manpower to take everything on. So we are focused in the green area. And you can see the green area is exciting enough. I mean, that's strong growth. It's an existing market. It's great opportunity for us. So market positioning. This is one of those slides where you're going to have to read it in your own time because I'm not going to go through the details. I've used this slide before, but there's a couple of really simple messages that come from this slide. Our polymers break through the speed wall. So what is this speed wall? And if you look at that chart, you see those black and the gray and some of the red circles. Those are commercial points of technology that gets used in the internet today. And you can see that none of those points are this side of that green wall. So our technology breaks through that wall because it's optics that goes faster. In fact, it's 3 times faster than current materials and modulation. And so, the takeaway at the bottom here is faster is good, 3x faster is way better. And we have the technology that breaks way through. And you can see, if you want to get technical here, you can see how you can utilize some of the higher data bandwidths. This is really exciting. The next slide is a new slide. It's a technical slide, so I'm not going to go through a lot of detail, but it's just showing you the history of where low voltage is coming from in the modulator devices. Now, we're proud to have Dr. Leonberger here, Fred. And Fred was the person that started off with the lithium niobate modulators back in the 2000s and really drove that industry. But that was using much higher voltages. They consume a lot more power. And I think, some people here are aware of that. But the industry is going to transition to very low voltage because they really have to do the high speed and the low power. And that's a great opportunity for us to change the whole industry to polymers. And so you're going from power hungry to high power to moderate power to low power. And you've got two curves here. One is a commercial curve, and the other one is an R&D curve. And you can see there's R&D work showing that folks have designed low-power modulators before. I've seen research papers. But commercialization is expected to happen pretty soon. And so this 1 volt metric of getting to super low voltage levels to keep the power down, that transition is happening. And so our timing in the marketplace is just, as I said last week in an interview, it's perfect. We're really excited. So I got a bunch of questions in the last 2 days about competition, and I get a lot of emails about who's your competitor. And so what we've done in this chart, and it is a very detailed chart, so I'm sure that you're going to analyze it a little bit more later. And maybe some of these metrics are not perfect, but they're the best ones we put together to look at how we stack up vis-a-vis the competition. And the polymers are the ones in the yellow and the green on the right-hand side. And on the left-hand side, you've got silicon modulators in that vertical. You've got indium phosphide. You've got lithium niobate. And then you've got TFLN, which stands for thin film lithium niobate, because there's been some talk in the technical community about using this type of technology. And you can see that there's relative differences between each of these technologies. But in general, when we compare some of these technologies to what we have, yeah, there's some seesaws here. There's some, maybe we're about the same as other technologies, but there's a lot of tick marks. A technology has a lot of merits, and it outperforms modulator technologies or different modulator technologies. And so polymer modulators outperform competitive semiconductor technologies, and that's really exciting. So when you start looking at some of the technical metrics, and I'm not going to go through each one of these, but this makes me really excited here. And then one of the important things that we talked about a year ago that we're going to talk about a little bit more is these 3 blocks here, standard PDK fabrication. Can your technology go into a standard silicon fab? Some of these can't. I mean, yes, the silicon one on the left can, but that's a really good advantage because that allows you to scale and to get volume. So what's unique about our competency? Well, let's have a look at some of the advantages. Naturally, very fast switching light. These are material properties of the polymers. So that's at least 2 to 3x faster than existing solutions using modulators. Naturally, very low power. Mother Nature is working with us with our technology. So it's 10x low power depending on how you want to design the device or the architecture. But that's important. And that's important for the system designers to get the power down. Easily fabricated using silicon foundries. And that's really important. As you saw in the last slide, you've got to be able to use the existing infrastructure. The last thing we want to do is go raise a ton of money, put a concrete slab, 4 walls, and call it a fab when there's already foundries out there. Utilize the existing infrastructure as best you can. And that's a capital-efficient process. The process is standard and does not require special toolkits. This one here has come up a lot in the last year and a half because of COVID. REO polymers are generated in our plant 1 mile away, so we don't have any security of supply issues. And so we generate our polymers. So we're not dependent on other people delivering stuff in or ships, being late and things like that. And so material is designed and sourced directly from ourselves. And the last one here is it's a low-cost addition to other integrated platforms, integrated photonic platforms. Silicon photonics, for example, can be boosted in performance. And that's really cool because our technology is additive. It doesn't really matter if it's silicon or silicon photonics. It could be indium phosphide. And so because we can apply it easily in a silicon fab. So polymers are unique in their properties. And so this is a cross-section of a slot modulator. If you've read a lot of technical papers, you've probably seen something like this before. But let me explain. I don't know if the light goes in between these 2 vertical stacks in the slot. You can see this one's on a silicon wafer. There's some silicon photonics, standard silicon photonics chip. You use standard photolithographic techniques, which you find in a foundry. The metallization is standard for the gate source contacts. You spin on the polymer, which is actually colored in yellow, and then you protect it with dielectric passivation on top. I mean, fairly straightforward. The tools you'd use to do this are nothing special in a fab. It's the same tools. And that's why it's really exciting. You don't have to invent anything special to go into the foundries to do this stuff. And so here's some pictures of modulators and different types of features that we've come back from the foundries. And you can see I've got some comments here. I mean, there's a foundry A and there's a foundry D. And so I just wanted to show everybody that we have stuff coming back from foundries, and it looks very nice. And so that process has begun, and I wanted to show everybody that, yeah, this is happening. And in fact, you can see at the bottom there, the takeaway is standard silicon fabrication components. And so, yeah, this is what we've done since we announced working with foundries a year ago. In fact, the next slide doesn't have much information on it. This is a grating coupler. You know, I think we had a press release about it 3 or 4 months ago. And the grating coupler takes the light from the waveguide and sends it vertically up. And it sends it up through those little trenches there. And you can see this is just an SEM of a grating coupler. Nice picture. But, you know, look at the scale here. This is 1 micron. So those channels there are 40, 50 nanometers. They're really tiny. But the quality is beautiful. And so some of the things you get from a foundry is really nice quality. And so it just gives you an example that it's, you know, you work hard with the foundries, you can get good results. The next slide is interesting. If you look at the size of a silicon slot modulator, it's teeny weeny. In fact, you look at the takeaway, size really matters, right? Go fast, go low power, but you want it small too, right? So all I'm showing here is like, you know, this is a CAD drawing of the slot modulators. It's just giving everybody this is a 1x8 array. And it shows it's 1 millimeter. These things are about, you know, 0.5 millimeter high. So you array them up, and you get 9 millimeters by 1 millimeter. And that's really important when you're trying to shoehorn these technologies into a box, a pluggable transceiver box. And in fact, you know, there was a competitor at the conference, the OFC conference back in March, that showed what they did with the lithium niobate. And this is thin film lithium niobate. And they put it into a module. You can see the printed circuit board. And you can see the thin film lithium niobate, which is that sort of gray chip. It's 9 millimeters by 15 millimeters. And it has 8 modulators on it. There's a laser there in gold. You can see some of the fibers that bring in the light. So 1 laser goes into 8 modulators, so 1 into 8. And it's taken quite a bit of space up. You did the same with us. You get 15, 30 times more modulators in the same space. And in fact, I mean, there's a little asterisk, only 30 times better. You could actually probably double that up if you really were trying to squeeze stuff in. And so what does that say? Not only are you high speed and low power, but we have the capability of sending a lot more traffic through that module. And the modules are really small, or the boxes are really small. And that is, you know, this is really exciting. This allows you to start thinking about these numbers called T's, terabits per second, not gigabits per second. It takes you an order of magnitude higher in data rate. And that's cool. But where would you use this stuff? Well, you know, where we enter the market is you have our modulators that go into these boxes. These boxes go into the switching and the router equipment in the data centers and the telecommunications network or the internet. And so you can look at this as polymer engines for pluggable transceivers. But we have high-speed engines that are really small. So this one here shows the roadmap that came out of Arista for the transceiver boxes. I mean, this is what these things look like. And, you know, if you look at the technical literature today, everybody's talking about 400G, and there's various ways to do that. And so they're shoehorning all this technology to get into this small box. And it's pretty tough. I mean, they're consuming a lot of power, and they're generating a lot of heat. But look at the roadmap. And this is what Arista showed back in March. They said, we're talking about 800, and we've got to go to 1.6, and then we have to go to 3.2. And quite honestly, I don't think folks are really understanding the technology that's going to go into these boxes. But if you start thinking about what we could do to this business, and so all I did was sort of modify that chart a little bit, and you can see, you start using that technology, you start extending that roadmap more than just a year, more than just 5 years, more than 10 years. And if you look at the vertical column, we're not talking about 1.6T or 3.2T. We start climbing that vertical ladder. That's incredible. And so what the technology is doing is enabling much higher speed with low power, and it's tiny. We can get it into the form factors. So the roadmap is enabled by high speed, low power, and tiny footprint polymers. So most important part of the talk, the business strategy. I'm sure everybody's interested in. So I think you've seen this slide before. It hasn't changed. I mean, I think I've got some bullet points here. Selling components, licensing polymer materials, tech transfer to foundries. And so what's number one? Prototype testing underway for future modulator sales as part of a silicon photonics platform. Working with the foundries to do that. Negotiating supply agreements for polymer materials as part of a generating licensing royalty. And discussing tech transfer as part of a process development kit, a PDK, with the silicon foundries. So we said we were going to do this last year, and we're doing this year. And the takeaway is to become a leader in the engineering and manufacturing of organic polymers. I mean, we use the term OLED. We use the term organic LEDs, right? Why can't we use the term organic mods or organic modulators? Because that's really what we're doing. And I showed this slide before, but I've added some new things, and the new things are in red, the red font. And yeah, we have a great patent portfolio, and we're building on that patent portfolio, and we're filing patents. And every time we have a patent issue, we do put out a press release and explain it. But in terms of issued patents, 60% of our portfolio are materials-related patents. And the other 40%, as you can see, are devices, high-speed PIC designs, and packaging designs. And so we've built that up aggressively over the last few years. Because when I joined the company in 2015, it was mostly just materials. So we've actually beefed up that side of things, and it's important to do that. And then about 50% of our portfolio is international. So the other 50% is U.S. patents. So that gives you some idea of our portfolio. And then there's two other areas here. We are always looking to acquire new patents. Because if your business model is based on licensing and tech transfer, then any opportunity to strengthen your patent portfolio is important. So yeah, if there's, we are reviewing opportunities, and if we do things, then we'll let you know about it. And on the filing here, we're very active, and we have to be very active if you're in this space. If your business model is based on licensing and tech transfer, you've got to be filing, and you've got to be putting your new ideas down. Of course, if there's trade secrets, then we're very careful about that. But if things that we feel are worth patenting, we do that. So partnering for success. We can't do everything ourselves. I mean, it will be inefficient to raise tons of capital to do everything ourselves. So we've got to work with foundries, and we've got to work with the transceiver manufacturers. And you can see that in the first bullet there. And then the second bullet there is, and I talked about this last time, you've got to be able to qualify your polymer process. It's your polymer recipe. That's what it is. A PDK is your recipe of how you fabricate these things with the foundries using standard fab techniques. And honestly, the unwritten thing that doesn't get talked about with foundries is it's not easy. I mean, you can do things in your own fab, and you can cook things in your own kitchen, but when you ask somebody else to cook the same thing, they may not get it right because they don't use the same techniques that you do, right? And it's the same thing here. When you're using foundries, they do get it wrong. Well, nobody really talks about that because, they don't talk about that business model. So you've got to be very careful about who you choose to work with and think really carefully about risk mitigation. Because, you got some magic recipe and you're using somebody else's kitchen, it may not go right because of something you haven't taken into account. And so that is something that we've actually focused on a lot for the last 12 months. And I'll give you some more detail in the next slide. But it's not something where you just say, yeah, we're working with a foundry, this is a piece of cake. Because they make mistakes too. And as engineers, we've got to manage that risk. And that's what we've been doing over the last year. And then, of course, we're getting tech evaluation and feedback. We're looking at licensing the polymer materials because that's the right thing to do as part of the business model. And the last one here is tech transfer. But the partnering allows us to really focus on our uniqueness. It's efficient use of capital, and it allows us to prepare for volume because these foundries are huge, much bigger than our little facility we have a mile down the road. So this is a new slide, and we haven't really talked about foundries much. But the first thing you're going to say is, well, we thought you were working with Foundry X, because everybody keeps asking me, who is Foundry X? But it's not one foundry. There's a lot of foundries here. And the reason we used the plural term of foundries a year ago is because if you're working with one foundry, and everybody knows this, the cycle time of a foundry is 6 to 9 months. So you put in your designs, because if you're working with one foundry, and everybody knows this, the cycle time of a foundry is 6 to 9 months. So you put in your designs, and you wait 6 to 9 months for it to come back. And what happens if it doesn't work? What happens if it doesn't have the performance you really need? And then you've wasted 9 months. And it's a slow process. And we've all heard, there's been supply issues. So even the foundries that said they can deliver in 6 months, typically they're a couple of months late. And so we're working with a number of foundries to mitigate that risk. And if you work with more than one, and if somebody's slow or it doesn't work right, then you've got another one. And so a year ago, we made a decision. It's not going to be one foundry. It's going to be a number of foundries. But what's the upside of this? It's more than just, mitigating your risk. It's going to help you to become ubiquitous because more people have your PDK, more people can utilize the technology, more people are going to want to license the technology. And so the right thing to do is to do what we've done here. You can see Foundry A to Foundry E. And I've given a little bit of details. At this point, we don't feel comfortable saying who the foundries are, but as the year progresses, we'll see. You can see silicon wafers. We've even got planned for indium phosphide because our technology doesn't have to go on silicon. It can go on other materials. And you can see on the right-hand side, we've now put dates because we feel we're at the maturity level where we're comfortable giving dates now, giving some guidance. And so, this is when we expect results from the foundries. So you'll see these slides online. But, we didn't do this last year, but I think it's time to give a little bit more detail about where we're going, what we're doing, and when we're going to have results. So deep activities. But if you think about these things for a second, it's not cheap to work with a foundry, but we have the resources to do that. But it's a lot cheaper to work with a foundry than it is to build your own fab. So that makes a lot of sense. This slide you've seen before, but I've changed it a little bit. I've added some companies, and I'm sure some of you will notice that. And I put in some foundries on this. But the interesting part of the marketplace is we can enter the market in many verticals. So you work with foundries. You might want to work in a customer, but a customer doesn't want to deal with you directly. They say, go to Foundry X, go to Foundry Y, or go to our contract manufacturer and work with them. That's typically what happens with the big guys. And so we've got to be in a position, we've got to be flexible enough that we can address this market in many verticals. And this is really what this chart is saying. And in fact, original equipment manufacturers, contract manufacturers, and outsourced semiconductor assembly and test. This is the packaging guys. The next slide you've seen before, but we've updated it. It's the technology roadmap, and in red font I've given some timelines. And so that's new. So what's at the bottom? We've shown this slide before, but we've never given any timelines before. And so you can see where we're going in terms of our unique 4 layers of uniqueness in our technology platform and some timelines to go with it. Now, this is a technology roadmap. This is not a product roadmap. And so we haven't got to the point of the product roadmap yet, but this gives you a really good idea of the technologies that's going to go into the products. And it gives you a good idea of when we're going to have that stuff ready. This one here, you've seen this slide before, but I've added timelines to it because we didn't show timelines last year. And so we're giving guidance on when are we going to be ready in terms of customer interaction, customer qualification, design, verification, partnership. And so the current engagement includes foundry partnering. And you can see it's not just one foundry, it's a whole bunch of foundries. So that takes a lot of work. And I thought it's appropriate that we give some guidance now. And the same thing on the next slide. I got a lot of requests to go see an update of the TRL slide. And so what I did in this one is, we're in that phase. There's no question. We're not in the high volume manufacturing phase, but we're in this phase. We're in the prototyping, piloting phase, and there's been some questions about what does that really mean. And so what I tried to do here is like, well, proof of concept prototypes with fabrication from silicon foundries. Second half this year. We have working modulators from foundries. So we're on track. Engineering samples using silicon foundry fabrication. So we're on track to that one too. But we're giving timelines to make sure everybody's aware. License and supply agreements. We're given a timeline there, and tech transfer definition and qualification, we're given a timeline there. So we now are planning the key milestones, but we're actually giving some guidance as well. Now, I think everybody's aware that we did some work with this company called Polariton in Switzerland, small company, got some really interesting device designs using plasmonics. And we just wanted some third-party verification of our material. It's a different design than what we're doing. So we gave them some material, and look what they did. They came up with a world record using our material. I mean, it's incredible. And so if you change the device design, but you're still using our polymer, you can still do world records. Isn't that cool? And look what they did in that slide. Now, you can't see it really from the back there. The next slide has it a little better. But they're comparing their plasmonic modulator using our material with microresonators, silicon microresonators. This is what everybody's talking about in the silicon world, silicon microresonators. And look at the performance of their device using our material compared to what all the big guys are talking about is the best thing. We're beating them. And so world record performance and outperforming competitive modulator designs and materials. And we didn't even ask them to put this slide together. They just did it. And so that's just our material. And it's so exciting when you see that. And in fact, the next presentation they did, which is March this year, they actually emphasized it even more. So these micro modulators, they need heaters, the temperature insensitive, and high performance EO polymer slot modulators outperform them. And the competition are very temperature sensitive, which limits their performance. So here we have, the big guys are saying the best thing about these ring resonators, but we just let a company we worked with have our material, and they just outperformed them just like that. And so that's third-party verification. That's not us. We're just providing the material. So depending on your device design, I mean, our stuff could probably go even faster. Sort of cool. Sample market reactions. I gave this slide over the last couple of years in the virtual format, and I think it's good to do it again because these are the things we hear. And I'll just go through quickly. In terms of high speed, Lightwave has the roadmap for decades in its polymers. Low power. We have to have low power modulators going forward. Optical networking and internet section. Your timing is incredible. The market needs your technology. We heard that back in March a number of times. Both 1310 and 1550 wavelength windows will be important, and polymers can do both. So we have the technology to use the wavelengths that the internet uses. Implemented them into silicon photonics. We did not need to create special fabrication recipes for the electro-optic polymers. Obviously, that came from a foundry. Electro-optic polymers are pretty easy to use. Polymers make silicon photonics much more exciting. Hybrid is clearly the direction. So hybrid means when you put a different material with silicon. So you got two different materials, a polymer and silicon. Scaling wafer size makes a lot of sense. So if you're on a silicon platform, then you can scale the wafer size. Viability and robustness. Polymers have come a long way. We expect them to be reliable. And look at this one here. I just had this one about, 5-6 weeks ago. Your polymers will be really great for AR, VR goggles. And at which point, I didn't have time to dig into this, but the fact that some technical person said, I see a huge opportunity here means, wow, this is another opportunity we can look at. Wouldn't electro-optic polymers be a great solution for optical switching? Yes, I absolutely agree with that. And so the feedback has been strong and constructive. Okay, now the tough slide. Because one of the things we do as a company is we try and be honest with ourselves, and we try and be honest with you. And where did we get to on the promises we gave you a year ago? And a year ago we said we're going to go do qualified sampling, progress with commercial partners, deeper commercialization. I mean, these were some tough goals, given where we were a year ago. And obviously we didn't get 8 out of 8, but I think we did really well. And you can go through these. We are testing foundry chips. We've got packaged prototypes in progress. We have qualified partners. We're continually testing. The QA and reliability testing is ongoing. We're engaged with customers. The last two are in discussion. I'm not going to give any public guidance, but the guidance I am going to give is that we're in discussion there. So I can't give us a tick, but I think we've come a long way since last year. The next slide is where we're going next year. So we have to have beta and qual plans, especially when in terms of sampling. So I think that's part and parcel of looking at guidance over the next 12 months. And I think that's important. We're at that stage now where I think that needs to happen. In terms of commercial partners, there's a lot of call in this room to say who you're working with as a foundry, who you're doing a deal with. Well, we're not at that point where we're comfortable yet, but over the next 12 months, I think we will be. So that's sort of giving you an idea of our expectations. In terms of deeper commercialization and qual of a product, we're going to give a lot more data and specifications. And I really would like to see the business model with somebody licensing the technology and the tech transfer, of course. If you've got a business model to do that, you need to prove it. And so I think that's, these are tough goals for the next 12 months, but I think we're up for it. We have a great team. We have a world-class team just a mile down the road, and we're really we've really accelerated we've accelerated over the last 12 months. So the focus is on commercializing polymers, and so let's have a look at some of the things that I'm going to try and preempt the Q&A session, so it doesn't go on for about 3 hours. Well, there's nothing there yet. Hold on. So these are some of the questions we always hear, and I want to thank the retail investors here because you're always sending us questions. Now, I know we can't answer all of them. We've had a lot of interest in the company. I think, was it 48 institutionals now? But 43? But really, it's the retail investors that have supported us over the last decade. I just want to thank everybody. And yes, I can't answer all your questions. I know you asked a lot of detailed technical questions. And I'm going to try and do the best I can here. So, do you have more info on partners? Question that comes up all the time. We are partnering with foundries. We haven't provided the guidance yet, but they are part of our goals. And what we did today is we've given a lot of insight of the type of foundries we're working with and some of the timelines. So we're trying to address that question as best we can. Do you have revenue guidance for 22, 23? Well, internally, of course, we do. Pre-revenue guidance clearly is difficult, and we are reviewing that. And we know that's a question that comes up all the time. So that's in progress. Announcement of a business deal. Well, as you can see from our goals, we're currently engaged with deal discussions. We're not at the point to announce anything yet. I know there was a lot of sort of anticipation. What are you going to say today? But I think the best thing we can say today is that this stuff's ongoing. And over the next 12 months, you're probably going to hear some more. Announcement of licensing the polymer technology. There are interested parties, and discussions are ongoing. So at this point, I can't say too much, but yeah, that's in progress. Announcement of tech transfer to, did I just do that one? Tech transfer to a foundry, and that's the same sort of answer. Yeah, we are in discussions with foundry partners, and that's ongoing this year. Product availability. We are providing better granularity on product availability in our roadmaps. So this year we've applied a lot more detailed timing, and as we get closer, we're going to give more guidance towards that. So that process is already started, and over the next 12 months, you'll hear a lot more. In terms of the business model, is tech transfer and licensing the best model for us? Well, we believe it is, given the vertical nature of the customer base. And the customers, when I say vertical nature, a lot of the customers have everything in place. So they design the chips, put the chips in boxes, put the boxes on printed circuit boards, put the boards into switches and routers, make the systems, and so they do everything. They know what they don't have. They know what they're weak at. And so as a company, you have to be flexible. They may say, yeah, we want to buy product, or they may say, no, go work with our foundry and go do a deal with them, and then we'll buy from the foundry because we've already got a pre-negotiated deal. So you have to be flexible in your business practice in order to be successful in today's environment. Will customers purchase directly from LWG? And the right answer is some may, and others will ask us to use their OEMs, CMs, and their relationships with foundries. And that's clearly what's happening. And that's well known today. How many folks do you expect to hire in the next 12 months? Well, we expect to grow about 5 to 10 folks. So, we've got good resources. We're careful at who we hire. We're picking world-class people. I think John's here as our VP of Engineering. I worked with John 30 years ago. World-class people. You need world-class people to be successful. You just have to. And the more you have, the more people get interested in your company and want to join you. And so that snowball is rolling, and it's really exciting to see. Finance. And I think if you've got finance questions, I'll let Jim do those afterwards. But how much financing is needed to break even? Well, we haven't provided that guidance yet, so that's a tough one to answer, although we are comfortable with our access to friendly capital. And yes, we've been talking to lots of different types of bankers over the last 6 months. We've been going to a lot of these conferences, as everybody's seen. And so, yeah, we're comfortable on that point. What is your runway? I think in our 10K it says GAN 2024, given the cash we have on hand right now. And our burn rate is roughly about 1.1 million per month. So that burn rate has gone up over the last year. But why has it gone up? Well, we increased the team a little bit, and we're working with lots of foundries, and they're not cheap. And so rather than put the money into buildings, we're putting the money where we can have the biggest impact for our technology. All right, next set of questions. Technical ones. Will the polymers get better in performance? Our performance is sufficient. We've seen great performance. Polariton got a world record with the current polymers. But we always strive to improve our performance to help customers. So that's not going to stop. We're getting great performance, but I think we can get a lot more. What is the reliability? Our latest results are exciting and stable with good lifetimes. I think we put out a press release yesterday morning, and we're really happy with the way things are going now. Are you doing Telcordia testing? Yes, we're doing long-term Telcordia testing on the devices. So that's in place. How does the polymer compare to the Polymer Plus compared to the Polymer Slot? Well, both are additive to silicon photonics to boost the speed and low power, there's no question. The slot has the smallest footprint, and that's really cool. As you can see, you can just do so much more with a tiny modulator. How fast do the devices run? Well, initial bandwidth, 70 gigahertz, which is 2 to 3x current today, and then 100 gigahertz and much higher is capable because we're using polymers. In fact, our testing system, as we said last year, goes up to 110. You can't buy anything any faster. That's the fastest there is. You have to extrapolate over that, after that. And so we're at the end of the test equipment. Is the yield good? Yes, we've seen excellent yields from the foundries. So in terms of the foundries, who are our foundries? I mean, I think everybody wants to know this one, right? They're folks we trust with our technology. So you've got to have a good relationship with them. Some of them are more inflexible than others, but you have to trust your technology with them. Because in the end, you're going to actually, if you think about what does a foundry do, they're in the business of just running wafers. All they want to do is run more wafers. So what we are providing is a new technology and the potential to run more wafers. And so you have to trust them. It's not our fab, it's their fab. You have to work with them. And we will provide updates as commercial progress matures. As you've seen from the goals, we'll go do that. How easy is it to use polymers in the foundry with a PDK? We believe it's straightforward. There's no new tooling. I mean, our polymer is in liquid form. You spin it onto a wafer, you cure it in ovens, use photoliths just like normal foundry processes. In terms of competition, how do we compare to thin film lithium niobate and other technologies, including barium titanate? And I showed you a chart that we've compared that. We believe we're a smaller, faster, and lower power. And you saw that from the chart I put together. Are we still the fastest and lowest power modulators? Yes, we have an incredible platform, and we see this not only extending for this year or next year, but for a long time. We think we're on the right technology for the marketplace. Do you expect other polymer companies to compete? Well, of course. I mean, if people see us being successful, they're going to jump in any way they can. And so, yeah, we're going to see people try and do polymer plays, try and keep up with us. We're going to see people doing semiconductor plays, barium titanate, thin film lithium niobate. Of course we are. Because this space is so hot because now everybody's realized the internet guys, the telecom guys, the datacom guys all need what we have, high speed and low power. And people now realize that, and they thought, well, if Lightwave's got a leadership, we're going to have to try and catch them up. But the good news is we're in the leadership position, and that's exciting. In terms of the customer, how's the feedback? It's positive. Our technology is attractive, and it's an enabler for them. We're actually, with our technology, we can enable their business. So when you think about the added value to the customer, it's not just low cost or it's high performance or it's low power. Can you enable their business with your technology? And that's exciting. What is your level of interest from customers? We have many requests for parts, so the interest is high. And the last one here is, what is the thing customers ask for the most? They all want the hardware. We've got people asking for hardware. And some people who ask for hardware, I'm not sure who they are. You get people out of the blue asking for hardware. So you have to qualify who you give your hardware to. But yeah, people want the hardware. So, last few slides. Leadership. Craig is a new person on the board, and this is Craig's background. He's been an innovator in optics, microfluidics, electronics, nanofabrication. He's had his own company. I've worked with Craig for, at least 20 years, and so we understand each other very well. Craig is extremely technical, and I think is a great addition to the board. And feel free to introduce yourself afterwards. And we worked together at Intel, and we worked at a startup together after that. And then John, John, will you just raise your hand? Hopefully you don't get mobbed afterwards, but John joined us in January, and I worked with John at Bell Labs in Tyco way, way back, and 35 plus years in telecom and datacom. John was one of the key pioneers of erbium-doped fiber amplifiers that were used for WDM systems back in the 80s. And since then, he's worked on pluggable transceivers, silicon photonics, a lot of qualification, very technical. Was at Sycamore, JDS as well. And so since January, we're really proud to have John on the team. And, our team is truly world-class. It's great. So, John and Craig are new members to the team. And the person who was on our board, who retired from our board, but we convinced to stay on our technical advisory board, is Joe. And I think Joe's been with the company many, many years. But his knowledge base of chemistry and materials is phenomenal. And so, yes, we still interact with Joe. We still get advice from Joe. He's not on the full board, but he's still very active, and this is great to have. And we probably will be expanding this because it's what we've discovered over the last 3 or 4 years is, we've got some really smart technical people. And we want to be surrounded with the best technical people to make sure we're doing the right thing and the vector's going in the right direction. If we're barking up the wrong tree, I want to hear about it now so we can do something about it. And you've got the best technical people, that's really good. So, yeah, we're really proud of our advisory board and our full board. And so to summarize, a bit of a sort of a complex slide, but, you can see here some of the things that we've talked about: material science, fab and testing, high-speed design, patents, huge markets, some of the Achilles heels of the industry. And so you can see some of the things here that make us really excited. So let's go to the slide I started with, which is the 4 takeaways. And what comes out of this slide, right? It's unparalleled progress. We've seen that. I mean, we have a unique technology platform, and of course, ubiquitous, right? We want it everywhere. And so if you think about it, those are the 3 words. If you're going to walk away with the 4 comments, walk away with 4 comments. If there's too much, then walk away with the 3 words. And one of them you already know, ubiquitous, right? So unparalleled, unique, and ubiquitous. Thank you. Yep. Jim, do you want to come up and help too? Okay. What we've done before for the Q&A sessions, if there's numbers-related questions, I'll let Jim do that. If it's techie-related stuff, I'll do that. So, yeah, we're open for questions.
Yeah, and so anyone who has a question, you can raise your hand. I'll note, due to technical issues, this is the only microphone we can use, so I'll have to walk over to you and walk back. But anyone with questions, just you can take them now.
Someone will ask it once. I thought you had hundreds of questions.
You covered them all.
I covered them all, I guess.
Oh, I guess I covered them all. There's got to be something.
Thank you for the presentation, Michael. That was really good. We've heard a lot about the multiple lanes, parallel lanes, particularly in silicon, so that they can get their bandwidth up a little bit higher. What do you see as the maximum lane count of a reasonable nature that the silicon folks can do, as well as what Lightwave can do, and still maintain a certain degree of reasonable complexity?
Technical question. So the move to single lanes, as I indicated, is important. One of the biggest impediments that we're going to see is not from the optics, because we have the optics solution, it's from the electronics. How do you get CMOS to go that fast in a single lane? And so the way people address that is they have multiple lanes. And so it's an interesting sort of area, because electronics is actually helping the optics, or has helped the optics over the last few years, and get to higher speeds. But in doing so, the power consumption from the electronic chips, the DSP chips, is huge. And they have to use 5, 6, 7 nanometer technology from foundries like TSMC, and it costs a fortune. So it's really expensive, consumes a lot of power. Now, if we provide an optical solution with this roadmap, it eases the constraints on the electronics. And it allows the power to go down. But I haven't checked to see if electronics can go that much faster. I think it can. But I think they will utilize lanes. But the good news is they will utilize much simpler symbol rates. So instead of going immediately to PAM4 or the QAMs, and I'm talking technical because this is a technical person, so excuse me for a second. But I think you're going to allow people to think about using NRZ as well as PAM4, which are much simpler symbol encoded schemes with electronics in order to get the speed up if you have faster optics. So what we're actually doing is we're alleviating some of the electronic issues. But I haven't really studied to think about how fast electronics can go. It's going to keep on improving because everybody's talking about 5 nanometer and going faster with CMOS. So that's not going to stop, and it never has. It's just what we're doing from the architecture standpoint is making life a lot easier for them. Sorry, it's a bit technical, everybody.
Oh,
We
well, okay. You said in a recent interview, and I can't remember, it was like within the last 2 or 3 months, you said something about 2022 is going to be a really exciting year for stockholders. You remember saying that? Yeah. Well, I mean, it's been written. Okay. Okay. So if you had to gauge that, if I said from 1 to 10, how excited are you for us and the company? Could you gauge it on a scale of 1 to 10 for us? 10 being it's beyond words of excitement.
Yeah, there's nothing like being put on the spot. So the first part of that question is do I look sad? Do I look unhappy? You know, we are really, I mean, we said in the slide number 3, we're really excited. So I don't know if that's a high number or a low number in your scale, but the more I'm with this company, and it's been, 5 years at the helm now, the more exciting it's become. So maybe we exceeded your 10 scale, I don't know. But the point is you can look at me and you say, is this guy really excited about what he's doing? Of course I am. I mean, this is a good way to look at this. I mean, I've been in other startups, but this technology is transformational, right? So we're not going to just do some new widget that goes faster. We're going to change people's lives. And in one of those interviews last week, is it Authority Magazine? They had this odd question. And the question was, what do you think is going to be the Black Mirror moment? And it's like, I've had some tough questions. And it's like, wow, how do I deal with this question? And I was fortunate because last year during COVID, I saw the British TV show Black Mirror. So I understood the question. It's like, whoa. And Black Mirror is, if you look into the future, what's the negativity that could happen? How bad could it get? What are some things that could go wrong? That's a Black Mirror moment. And, you know, when you see something that's as transformational as our technology, you know, what I put in that article is what happens if we get information overload? Some of us can deal with it. I mean, I deal with it. Jim deals with it. But some of us don't want to have information overload. It's tough. And so, you know, what we're providing is an internet that can deliver a lot more bandwidth to everybody's home. So you can have 5 televisions running at the same time if you want to watch 5 televisions running. I won't do that, but you know that's the type of thing you can have running. I mean, one video platform here, another video platform there. Kids have another video platform. You got the bandwidth to deal with all this, and so that's, you know, as we look out 5 or 10 years, it's like, yeah, there might be some negativity there, but in terms of bringing our technology to the forefront and enabling a much more faster and lower power internet, yeah, this is really exciting. And so I am. And the reason I am is because, you know, we're doing great work and we can see the impact. There might be some negative impacts, but the positive impact is huge. And I haven't really given you a number from 1 to 10. I would say it's more than 10.
Could you further define what the difference between partnership and commercialization mean with regards to revenues? Because, you know, seeing the time frames, I'm just curious, should we expect actual revenues coming in closer to 2024 on a commercial timeline based on the slides? So
we said we weren't going to provide revenues, so I'm not going to provide revenues. But if you've got a commercial, let's say for argument's sake you do a commercial business deal with a foundry, and the foundry accepts your PDK, then, yeah, the foundry can generate more business. So that way you can bring in revenues. So when you look at the business model, you know, you can, the traditional way of selling components, right? I mean, you make a component, you sell it to the customer. The model we're looking at is, can you generate revenues from royalties, and royalties of transferring your technology to a foundry so they can use your material and they can further their business. That may still be the customer. As I indicated, the customers may not want you to sell directly to them. Just say, go have your stuff in the foundry and that's fine with us. And then we'll buy from the foundry. So it may not be a direct, but yes, it does have a relationship to revenue. And the more we get comfortable, the more we will give guidance to them.
Yeah. No, I think I got a mic on. No, but the other thing, when you take a look at the royalty plan, I guess is a layout that we, but I don't want any feedback on this. Anyway, they're both working, right? If I get it too close, it'll. Anyway, there's dollars that come into our pocket when somebody signs up, okay, and then there'll be royalty based upon the devices that they sell, all right. And I think the tech transfer really gets into where you're working with the foundries, working very tightly with the foundries to come up with the different PDKs, which means you just don't hand them a recipe and turn them loose. We have to work with them and get lots of wafers back, test those wafers, go back to them, because we have to give them feedback on everything before. So I think that's where the tech transfer is versus just if we have all these patents, you want to use it for type X work, then we could market segment. We'll just give it to you and you'll just pay us a fee for doing that. The tech transfer means we work very closely with them, and we're doing that today. So. And by the way, they're excited to work with us.
Thank you for the presentation. Would you say that the foundries are in competition with one another at all? Are they aware of their status between the 5 that you mentioned, 5 to 7?
So we haven't given any guidance on our foundries, and I don't know if Foundry A knows what Foundry B is doing in relation to ourselves. So we haven't knowingly given any information out. Could they be competitive with each other? Perhaps. But this is an opportunity for foundries to take a new technology and run with it. So from my standpoint, how do you get to being ubiquitous? Is it just one place that does it, or is it lots of places that do it? And so a model to mitigate the risk of success with using foundries is use more than one. And so, yeah, you're seeing a bunch there that we put up, and I dare say there may be competition. But I want to see the technology everywhere. I mean, it's okay to have a great technology, but it's like OLEDs. I want it like OLEDs. I want it everywhere. So, yeah, there's going to be competition, I'm sure, but we'll work through those things.
First of all, thank you for having us here. It's a very exciting day. Thank you to the whole team who's been working on this. I think you've brushed on it very quickly, but in the industry today, we've heard from a lot of different players speaking about building a new ecosystem. So when I see Lightwave Logic within that ecosystem of companies that are trying to do something very transformational, as you say, how affected were you in the last 12 months, or do you expect in the future to be held back by other companies within the ecosystem that maybe do not progress at the same speed you do? I think you've maybe touched on it during the presentation, but if you can shed a little more light on this.
So just because we have a polymer technology that does really good things doesn't mean it automatically goes into the industry. You've got to have the electronics and the packaging to support you. So like, for example, you get a modulator working at 100 gigahertz, that's a special package. So that's something that you have to work with the rest of the industry players. And this is why we have to partner. We can't do everything ourselves. So we can't do the electronics. We're going to have to work with electronics chip manufacturers. We're going to have to work with the packaging guys, the transceiver guys. And so we're aware of that. And the interesting thing to address the ecosystem question is when a few of us were at the Optical Fiber Conference in March, we've been told by customers over the last 18 months, you have to have high-speed and low-power modulators. But it actually came out into the open at this year's conference, and everybody was talking about it. And so when things come out into the open like that, then the race has started. Right? Competition has started. People realize that where we are is we're in a really hot space. And that's just, and so now, the infrastructure, the ecosystem, the electronic guys, the packaging guys, the foundries, they all now realize. And you look around, you're seeing press releases by foundries now. You're seeing people talking about silicon photonics more in the last 6 months than we have in the last 5 years. So the ecosystem is now aware that it has to upgrade. And we're in a nice position. So yeah, you're right. And we can't do everything, but we have to work with people. And we have to partner with people, and that's happening. Oh, you want an extra question?
One more technical question. The limitation that I see right now is Lightwave is unable to see truly how fast the modulators go because we are running into the bandwidth of the testing equipment that's available out there, whether it's Keysight or Tektronix, whoever it may be. Is Lightwave currently working with the Keysights of the world to expand the ability to test it at higher bandwidths?
So the best way I can answer that question is we have a pretty tight relationship with the test equipment manufacturers. And for the test equipment manufacturers to have higher performance equipment, they need higher speed optical devices. I'll leave it at that.
Your market size projections, 40-60 billion for telecom and data centers. That includes the total revenue of transceivers. Could you add some color as to what portion modulators are of the transceiver market?
So in a transceiver, which is a box, basically a metal box with a printed circuit board inside, the majority of the bill of materials goes into the optics. And so depending on the speed and the complexity, it could range from 20-30% up to 80-90%. And so if you have a technology that enables that box to do something the competition doesn't do, then the value you get out of the optics in terms of the percentage of bill of materials is much higher. And so, yeah, it can range. But when you start looking at 800 and 1.6 terabit per second, I mean, it's going to be a big part of that bill of materials. Now, we haven't given any guidance on details, but generally speaking, if you've got a technology that enables your transceiver box to do something that nobody else can, then you can extract that value, and we're not going to leave it on the table. So, yeah, we're aware of that. But it's a good question, yeah. One more question? I'm never going to wear white ever again, right? Okay. Yeah, go ahead.
What is the process that management or your investor relations will give, say a foundry C decides, okay, we have a customer, they want your product, we're using it, and there is a revenue stream starting to appear. Will it just appear on a filing? Will you come out in a press release? Will there be a joint press release? Does the foundry come out and say we are now using Lightwave technologies? I just want to try to wrap my head around the process that you will share with this retail group that's been extremely loyal. How will that process take place from your side?
So as we indicate, we expect that process to mature in the next 12 months. And you could have a number of interesting scenarios. You could have this scenario where we would want to put a press release out with Foundry X because we want to, or the other way around. Foundry X comes to us and said, we want to get a head start in this technology vis-a-vis other foundries, and we want to go do a press release. And so that process, is going on. But at this point, we haven't reached that threshold, in our comfort level to give guidance. But each foundry has their own way of dealing with it. So if you look at different foundries across the board, they have their own ways of announcing whether it's a single company, joint venture, partnership, or a bunch of companies they're working with. But we always, when it comes to foundries, you have to think about what their business model is. If you look through the optics of them, all they want is more wafers. They want more wafers to run through their fab. So that's what motivates them. And so you have to think about that and how you are impacting them or how they see themselves generating their own revenue. So I would say that there's not one solution here, but it's something we're working with each of the foundries. And if we feel comfortable, we'll go do one of those things. There was one last question at the back. Let's do one last one.
So to this gentleman's question on the management and the announcements, you just mentioned it was within 12 months there would be some guidance. I just wanted to make sure I heard that correctly. Seems like positive guidance that what was said. The other thing too on the wafers and these foundries pumping out wafers, it would seem that yes, they would want to pump out as many wafers as possible, but if you were able to allow them to pump out the same amount of wafers at twice the speed with half the power, they could charge 10x on that wafer because it would be that much more wanted in the marketplace. So I just wanted to hear your comment on that.
Typically wafers, well, the first part of your question is I've written down what our goals are in the next year. It's in stone. So yeah, we'll make announcements as we feel comfortable. So I think that was pretty clear. But in terms of foundries, I mean, they have a bunch of process steps. If you want to get a wafer through faster, let's say it's a cycle time of 6 months. You put in your design, it takes them 6 months to run through the foundry, you get your stuff back. You can pay more money. You can do hot lots to get it, go to the top of the queue to get it come out faster, but it costs a lot more money to do that. And so foundries do offer that type of service. In terms of assuming that you have the same steps in the recipe and you want that wafer to come through twice as fast. That does happen, and it just depends on the need of the customer. And so yes, if they really want this stuff out there and the customer drive is strong, yeah, they can do the cycle time instead of in 6 months, they can take it down to 4 months or even 3 months, depending on who the foundry is and what sort of availability they have. And so hot lotting is certainly something that occurs in foundries, and we're aware of that. So it's something we do take into account.
I think you're also asking about cost performance, aren't you? So one, they're going to get what the market will bear, right? And if you're adding that much better performance, they're going to be able to get more money for those chips, right? And then in the end, that helps us because it'll be a royalty-based program.
All right. Well, I want to thank everybody, and we'll be here to answer, I guess, a few more questions if you would. But thank you for listening.
You had a question?